Section 7.4 is on scientific notation. Scientific notation is a way of writing really big or really small numbers, kind of a shorthand so we don't have to put a whole lot of zeros into a number. So the form for this is a times 10 to the raised to the power of n, where a is a number that's greater than or equal to 1 and less than 10, and n is an integer. Another thing to notice is we use an x for the multiplication. So a is going to be any number that's 1 or bigger than 1, and it has to be less than 10, and n is any positive or negative whole number. Let's take a look at a couple examples here. Express each number in scientific notation. So I basically need to start by writing this as 9.3. So I can only have one digit. In fact, I have to have one digit to the left of the decimal point, and then any other non-zero digits need to be to the right. Times 10, and I need to write it raised to some power. Now the easiest way to do this is to just kind of go like this. 1, 2, oh, my original decimal point's here. I need to get my decimal point here between the 9 and the 3, so I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 to get the decimal point there. So this is going to be 9.3 times 10 to the 15th power. And because this is a really large number, I don't even know, millions, billions, trillions, something like that, my exponent is going to be positive. When the exponent is positive, it's a really big number. Now in this case, I have number 2 here. I have this very small number. I need to have my decimal point right here between the 6 and the 4, because remember I can only have one digit to the left of the decimal point and all the rest of my non-zero digits to the right, times 10. And in this case my exponent's going to be negative because this is a very small number. It's less than 1. So let's count how many places I have to move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be times 10 to the negative 9. For these examples, it says express each number in standard form. So take it out of scientific notation and write it with all the zeros. So I'm basically going to have 1, 1, 4, and I need to move my decimal point 6 places to the right. So 1, 2, and then I'll need 4 zeros after that. Is that correct? 1, 2, 3, 4, 5, 6. My decimal point would be right there. Add your commas, and so I have 1,140,000. Similar for number 2 here, 8.0346 times 10 to the negative 9th. I'm going to need a decimal point and a bunch of zeros. Actually, maybe I'll start with my number. I'm going to need 8, 0, 3, 4, 6. Originally my decimal point was here between the 8 and the 0, and I need to move it 9 places this way. So that's going to give me 1 to there. So I think I'm going to need 8 zeros out in front here. 7, 8. A decimal point, and I like to put a 0 in front of the decimal point so that I know that that actually is a decimal point. Let me count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is correct. If you're doing one of these that has a negative exponent, it's going to have a lot of zeros in front. Be sure and give yourself plenty of room. Now, here's a few examples where we need to find each product or quotient. So we need to do the multiplication or division and write our solution in both standard form and in scientific notation. So I have 6.5 times 10 to the 12th times 8.7 times 10 to the negative 15th. So what you want to do is multiply the first two parts, in other words the number parts that aren't a power of 10, and then multiply the powers of 10. So 6.5 times 8.7 is 56.55. Just do that in your calculator. Times 10. Now I'm just going to deal with my exponents like I did back in section 7.1. Since I'm multiplying 10 to the 12th times 10 to the 15th, I just want to add my exponents. That's going to give me 10 to the negative 3rd. Okay, now that's actually not in scientific notation because my decimal point is in the wrong spot. I need to have my decimal point between this 5 and this 6, in front of the 6, not after the 6. So there's a couple different ways of thinking of this. I could take this expression right here and write that, just that, in scientific notation. Okay, now I need to figure out what my exponent was. What I did was I moved the decimal point one place to the left. And in doing so, what I really did was took 56 something and made it 5.6. What I did was I divided it by 12. I'm sorry, divided it by 10. So in order to kind of make up for that, I need to add a power of 10 over here. So I need to multiply by 10. So basically, take a look at this, 5.655 times 10 to the 1. So if I multiplied this by 10, I'd be moving the decimal point 1 to the right, and get back to what I started here. And then times 10 to the negative 3. That's going to give me a final answer of 5.655 times 10. Add your exponents to the negative 2. Another way to think of this is, given my original answer here, in moving this decimal point to the left, which I had to do to get this answer down here, I divided by 10, so I have to multiply by 10. Multiplying this times 10 to the 1 is going to give me 10 to the negative 2. Writing that in scientific notation, I need to move the decimal point 2 places to the left, so it's going to give me 0.05655. So there's my answer in both scientific notation and standard form. So 7.8, example number 2, 7.8 times 10 to the negative 4th. So what I need to do here is be careful. Don't just multiply 7.8 times 2. This is 7.8 squared. So using your calculator, that's 60.84, not 48, times 10 to the, now remember, multiply your exponents here, 10 to the negative 8. And again, I have an answer that looks like scientific notation, but it's not exact because I need to have, my answer needs to be in 6.084 times 10. Now this is going to be like the same example I did before. Because I moved the decimal point one place to the left, I was basically dividing this number by 10. So to offset dividing by 10, I need to multiply by 10, and this is going to turn into 10 to the negative 7th. There's my final answer in scientific notation. And in standard form, I'm going to need to move this decimal point 7 places to the left, which means I think I'll have 6 zeros and a 6084. So is that correct? 1, 2, 3, 4, 5, 6, 7. Okay, so there's my answer in scientific notation and in standard form. Now to do quotients or division problems involving scientific notation, do the same thing. Here I have 2.3958 times 10 to the 3rd divided by 1.98 times 10 to the 8th. Divide the decimal pieces here and then divide the powers of 10. So when I do this division in my calculator, I get 1.21, and then subtract your exponents here. 10 to the 3rd minus, or 10 to the 3 minus 8 is 10 to the negative 5. And actually, I don't need to move that into the denominator because scientific notation is the one time when negative exponents are okay. And this is already in scientific notation form because I have exactly one digit to the left of the decimal point. In standard form, I need to move this 5 to the left. So I think that's going to give me 4 zeros and a 1, 2, 1. And there it is in standard form. And our last example here, 1.305 times 10 to the 3rd divided by 1.45 times 10 to the negative 4th. Do the division of the decimals in your calculator, and that gives me 0.9 times 10, and now subtract your exponents. 10 to the 3 minus a negative 4 is 10 to the positive 7. Now, that's not in scientific notation because I need a non-zero digit to the left of the decimal point. So I need to move my decimal point one place to the right, and in doing so, I really multiplied this by 10. 0.9 times 10 gives me the 9 that I need to have. Since I multiplied by 10, to offset that I need to divide by 10. So that's going to give me 10 to the 6th. So 9 times 10 to the 6th, and writing that in scientific notation means for my decimal point here I need to move 6 places to the right. So that's going to give me 6 zeros, or 9 million.